Now students, we'll take up a next problem on rectilinear motion. So it reads, the length of a track is under repair for a length of 2000 meter, where the permissible speed is 10 meter per second. The train approaching the track with a speed of 25 meter per second has to retard to a speed of 10 meter per second in a distance of 200 meter. After crossing the repair track, the train accelerates to the full speed from 10 meter per second to 25 meter per second in a distance of 1600 meter. Find the loss of time due to repair of track. Okay, the question says that the total length of a track is, say it is 3800 meter. So in that total length of 3800 meter track, a length of 2000 meter track is under repair, right? So the train, if it is approaching from point A, is at a speed of 25 meter per second. It has to reduce its speed to 10 meter per second in a distance of 200 meter. It is given here. Speed of train 25 meter has to retard to a speed of 10 meter per second in a distance of 200 meter. So train which is traveling at a speed of 25 meter per second has to retard to a speed of 200 meter. Then from there on, the permissible speed on the repair track is how much? 10 meter per second, and that repair track is for a length of 2000 meter. Then after the train crosses this point of repair track, it can increase its speed to the original speed, that is 25 meter per second, for a distance of how much? 1600 meter. Now you have to calculate what is the loss of time due to repair of track. Okay, suppose if there was no repair to be carried out, whether the speed would have changed? No, the speed would have been same, that is 25 meter per second. If there was no repair of track, then train would have traveled directly with a speed of 25 meter per second for this distance. So if I take from the figure the total distance A, B, C, D as S1, S2 and S3 divided in 3 parts, 200, 2000, 1600, it is 3800. So if there was no repair, the train would have traveled with the uniform velocity, and the time taken by the train would be what? S is equal to ut. Because it is uniform velocity, so acceleration is what? Acceleration is A equal to 0. So for a total distance of 3800 meter, initial velocity is 25, time taken would be what? Total time 152 seconds. So train would have covered this distance of 3800 meter in a time interval of 152 seconds. But since there is a repair work to be carried out for this length of 2000 meter, so we have to calculate what is the time taken because of this repair work. So firstly what I'll do is I'll consider portion AB. So portion AB, what is the data we know with respect to that? So distance between A and B is 200 meters. Initial velocity of the approaching train is 25. It is decreasing to velocity of 10 meter per second. So train is undergoing retardation. So using this relation, V square minus U square is equal to 2AS. I'll calculate what is the retardation or negative acceleration. So negative acceleration will represent it as minus sign because speed is reducing from 25 to 10. So again using relation V is equal to U plus AT. So I'll call this T1 because it is with respect to this distance S1. So I'll calculate what is the time required to cover that distance of 200 meters. So it is 11.43 seconds. Okay, so train covers a distance. Okay, hope you understood with the first part. So first part, once again I'll repeat. With respect to this first part, I know the distance is 200 meters. Initial approaching velocity is 25. Final velocity at the end of point B is 10 meter per second. So I'll take those data, S1 200, U 25, V 10. We'll calculate the retardation acceleration and the time required to cover the distance of 200 meters. Okay. Similarly, moving on to the second part, which is a repair portion. So repair portion is from B to C. This 2000 meter is under repair. So you can see here, initial velocity at this point of the train is what? 10. Final velocity also will be 10. So it is traveling with the uniform velocity of 10 meter per second. So distance, the information with respect to portion BC is what? Distance we know it is 2000 meters, so I'll denote it as S2. Initial velocity is 10 meter per second, final velocity is also 10 meter per second. So since it is traveling with the uniform velocity, means what? Acceleration is equal to 0. So we have a relation S2 is equal to ut plus half at square. So acceleration is 0 means this portion becomes 0. So S2 is equal to u into t2. So S2 we know it is 2000, initial velocity is 10, and time taken should be calculated, and it is 200 seconds. Similarly, moving on to third portion, which is this. At this portion, initial velocity of the train becomes 10, final velocity it will be 25 meter per second for a distance of 1600 meter. So S3 is 1600 meter, initial velocity is 10, final velocity is 25. So again calculate what is the acceleration. So v square minus u square equal to 2as. Initial velocity is 10, final velocity is 25. Calculate acceleration, you will get 0.165 meter per second square. Substitute that in this equation. So this T I'll call it as T3 because it is with respect to the third part. So using that I'll get the time required to cover a distance of this 1600 meter is how much? 91.42 seconds. Now because of that repair work, what is the total time taken by the train from this point to this point, from A to D? It is add all those times that we have calculated. So T1 is 11.43, T2 is 200 seconds, T3 is 91.42. So we'll get 302.86 seconds. So because of repair work, this is the total time taken by the train. So if there was no repair, what was the time taken? It was 152 seconds. But because of repair, it is 302.8 seconds. So the time lost due to repair is how much? This total time minus 152 seconds. So time lost is 150.86 seconds. I hope you are clear with this problem. Thank you.